I think I'm live. And let's see. Mhm. I hope my audio quality is fine because okay, this tab I wanted here. Yeah. Let me check the audio and everything. Okay, my audio seems fine. It seems fine. Yeah. I'll wait for a few minutes before starting like the discussion of this particular contest 506 weekly contest 506. I'll see if people joins or not. Okay. Meanwhile, I'll check my setup. uh yeah, let's start. Okay. I want to pin this chat here, keep above others. Right, so weekly contest 506. This was an interesting contest, and I did pretty well as per my past performance. I got around 2k rank, and yeah, so usually I am able to solve like 2 or 3 questions, but still the rank is like you can see 6,000. And last time I got 4,000, I guess. I solved 2 questions. Yeah. So I have been doing Leetcode very actively, as you can see. And yeah, this contest was nice. And let's start with the discussion. So let's do some retro over here. Q1 was very simple, just an easy question. And yeah, let's see the Q1. So you're given a positive integer n. Let digit sum be the sum of the digits of n, and let square sum with the sum of the squares of uh, the digits of n. An integer is called good if square of sum minus digit sum is greater than equal to 50. Return true if it is good, otherwise return false. So you simply take a sum and a square sum. You keep track of those. You find out a digit, divide by 10, so that digit is gone. And sum plus equal to digit square, and if square minus sum is so this is simply the condition checking. And I was able to solve it very quickly, like 1 minute 1 second. I think the first rank one took 1 minute 21 seconds. So I was pretty quick. I don't see anyone solving it that quickly. Yeah, 118 is there. But yeah, I was able to solve it. Oh, 58 seconds. There are people. Yeah, so I was able to solve it relatively quickly. And yeah. Q2. So Q2 was interesting. It took me a lot of time. So you can see I solved the first question in a minute, and then Q2 I solved it in like 53 minutes. It took me around 50 minutes to solve Q2. I would say I was wasting, or not wasting, I was thinking about sliding window in Q2, and I wasted some time there. and then realized that sliding window won't work because we can't shrink or maximize the window as per the given question. So let's go through the question first, and then we will go over the solution, what I have done. Uh, Frequency balance subarray. You are given an integer array nums. Define a frequency balance subarray as follows. If the subarray contains only one digit value, it is frequency balanced. Otherwise, there must be positive integer f such that every distinct value in the subarray occurs either f or 2f times and both the frequencies among the distinct values. So I'll quickly tell you what the question says. So if we have this array, I take 1, 2, sorry, 1, 2, 2, 1, 2, 1, 2, triple 3, 2, triple 3. So in this you have a subarray which is 2, 1, 2, 3, 3. So this subarray if we take, the frequency of 2 is 2, the frequency of 3 is 2, and the frequency of 1 is 1. So max frequency in this case is 2, and all the other uh, elements which doesn't have a frequency of 2 should have a frequency max divided by 2, that is 1. So 1 has a frequency of 1, that's why we have this subarray as our answer. Right, so this is the question. You have to find the length of the subarray, not the subarray itself. So 0, 1, 2, 3, 4, 5. 5 is the answer in this case. And yeah, so basically what I did was, I'll go through what my intuition was. So 1, 2, 2, and then we have 1, 2, triple 3, I guess. Right. Yeah. So my intuition was in this question that you have to go through. So the constraint were like 10 to power 3 and is 10 to power 3, so we can go in square here. I'm not so sure if it can be solved in less than n square. I hope not. But what I did was I took an I and a j uh, pointer, and I went through all the subarrays, like starting from here this one, then starting from here this one, length 2, length 3, length 4. So I went through all these subarrays, and then I would move I here, then all the subarrays starting at this 2, right. And what I basically want in a subarray is that the max frequency, whatever it is, x, and all the other uh, frequencies should be x by 2, right? Okay, it should be x by 2. This is what I want. Now when will it be possible? It will always be possible, only be possible when the size of your frequency is either equal to 1. So when you have a single array, let's say this one 3, 3, 3. So here 3 has a frequency of 3, and there is no second frequency or like other frequencies. So this is also a balanced subarray. Yeah, balanced subarray, frequency balanced subarray. Right. So either this, or you have a condition when frequency dot size is equal to 2. So this is an important case. So this is a case where all elements are equal, and this is the case when you have two frequencies. So if you have two frequencies, x and y, one of them will be greater than other because it is a key of a map, right? They have to be distinct. And whatever the max of these is, so max of x and y, and whatever the min of x and y is, Basically, you want max of x and y. Let's say x is max and y is min. And you want to check if x is equal to 2 into y. If this condition is true, that means you have found a frequency balanced subarray, right? So this is the whole intuition behind this problem. Now the interesting part is, let's say you keep a frequency array. I'll just do one thing. I'll sorry, I'll copy this one. So let's just copy this thing, paste it here. Okay. Uh, yeah. So basically, what you want to keep track of is the frequency first. Let's take a sub array. Let's take the sub array, which is the answer. Let's take that only. So it was what, 2 1 2 3 3, this one, right? This is our answer. So what would happen in this case? How would your frequency array here look like? Let's see that. So your frequency array will be something like 2 occurs 2 times, 3 occurs 2 times, 1 occurs 1 time, right? Now the thing here is, you have these frequency corresponding to each element, but you would want a different, I would say a different map, which would keep the inverse of this, basically. So like somewhat an inverse of this. So it would say like, the frequency, it so this is basically your element frequency map. I'll write f. This will be f and how many times this frequency has occurred, right? So this is what this other map will be. So what this other map will be, this is the frequency, right? So 2 occurs 2 times, 1 occurs 1 time. This is your another map which stores the frequency is occurring how many times, right? So this is the map that we want to keep a track of. And whenever, so this map has a size of 2. So I think this I did it wrong. It's not frequency, it's your map. When your map size is 2, and here your map dot, I think size should be equal to 1, right? If I'm correct. Yeah, map size should also be equal to 1. So there should be one element with one frequency. Yeah. Okay. So this is the map which stores the how many times a frequency is occurring. And from this map, you can easily calculate. So whenever this map size is equal to 2, you can take the max and the min, and you can check that max is equal to 2 times min. If this condition satisfies, you have a balanced subarray, frequency balanced subarray. And how would you keep track of this particular map is a bit interesting, because it's not very straightforward. Uh, so we have 1 2 2, um, 1 2 1 2 3 3 3. Right. This is what we have. So let's say I take this subarray only. Uh, when I was at this position and I was in this subarray, right? And I want to extend this element. So what do I have to basically do? I would have to do like frequency dot put, or I'll write it in easier terms, nums of j. Let's say j is here, uh, plus plus, right? This is what I would want to do. So what this operation is basically doing, so it is so frequency of 3 was previously 1, so this is previous, before this operation was 1, and after this operation the frequency of 3 becomes 2. So what you would have to do in your other map, which stores f comma number of times the frequency occurs, what you would have to do here is uh, you would have to remove this somehow. So remove this somehow, this frequency, and add this somehow. So what you will do is from your map, you will say that your old frequency minus minus. So old frequency can be frequency dot get frequency of nums of j, right? This is your old frequency. So you do a minus minus on this, and if map of old frequency is 0, in Java you will have to remove this key, remove key. And what you would want to do is map of the new frequency should be plus plus. So new frequency will be, after this operation you can calculate the frequency of nums of j, right? This is how you can basically maintain the frequency and number of times that frequency occurs. So that's how I did this particular question. Let's go over to the Java code. I think now it will make much sense. So for I'm traveling till n, and I take two maps. One is frequency and one is the other map that I was saying, which is tracking the number of times a frequency is occurring. For j is equal to I till n, frequency dot put. So this is basically you are saying something like frequency of nums of j plus plus, right? And you could, I in the contest I wrote it like quickly, so I didn't take this variable old frequency and new frequency. I think this simplifies things a lot. But basically what I did was I calculated this is new frequency, and I just said that old frequency is f minus 1, the new frequency minus 1, simply, right? So you do map dot put, you basically decrease this one, so this becomes your map of what frequency of, not frequency, map of what we did here. Let me go back. Yeah, map of old frequency minus minus, basically this is that. And if this is 0, then we remove it from the map, and this is basically your map of new frequency plus plus, right? And if map size equal to 1 and frequency size is 1, then the entire that sub array is your answer. Otherwise, if map size is equal to 2, only then what you do is I used iterator. So I did map dot key set iterator, and f1 and f2 I took out both of these elements. The maximum frequency is max of these, the second max is min of these, and if your max of f is equal to 2 times of this thing, second f max f, then you have a balanced subarray, frequency balanced subarray, and then you do math.max res result and then the length, and then you return the result. So this is what I did. This solution got accepted. Yeah. So this was second question. I think it was a bit tricky, but not that tricky. I wasted a lot of time in thinking about like the sliding window approach. That took time. So we are done with Q2. The Q3, I think it was a greedy. Yeah. So let's see the question first. Maximize sum of device ratings. The problem statement, I read it like twice and then it made sense to me, but it's not a very difficult question. You have to make some observations and you will be good. Right. So basically you are given, I'll simplify the problem. You can read it if you want on your own. But I'll tell you what the problem says. So we have a 2D array. So I'm writing rows here, 2 comma 2. And for each row, basically, your score is the minimum element in that row. So score for this will be 1, score for this will be 2. And now your sum of score is 3, right? So this is your sum of score. Uh, and the question says maximize this sum of score, and a operation is given. What does the operation says? Operation says select any row, pick any element, and move it to some other row. So select row, pick any, select a row which is not previously selected, and then pick any other row. And so this is your first, second step, and third step. Third step, do we have? Yeah, mark row as visited or selected. So this is your operation. And if I tell you the first example, which is 1, 3, 2, and 2, if you take the score without any modification, it will be 1 and 2, which is 3. But you can do one thing, you can take this 1 and move it here. So now it becomes 3 and 1, 2, 2. So the score now is 3 here, 1 here, which is 4. So 4 is our answer in this case. Yeah, so this is how we are applying the operation. Uh, Now, there is an observation to be made here, that you have to be greedy in this case. And why you have to be greedy is because uh, you have basically two options. Uh, Either take the minimum in the score, or you take the second minimum, right? You take the second minimum. Second minimum how? By doing swap operation, right? So basically what you can do is, for all the rows, what I did was I maintained a global minimum, right? And what I did was I calculated the second minimum. And these second minimum I then added to a priority queue, which was a max heap, right? Which was a max heap. And I'll tell you why I did that. So basically, what will happen? Your global minimum will become 1 here, because this is you calculate the minimum of this row, and that will become the global minimum. Then you compare 2, which is the next global minimum. So yeah, so 2 is not less than 1, so global minimum stays 1. And this is the second minimum, and this is the second minimum. So these two are your second minimum. Second minimums you will put in queue. And the reason I put it in a max heap is I want to be greedy in picking things. So what I mean by being greedy is, basically I want to do this operation. I want to uh, collect collect the minimum or the global minimum. Can you explain the second one? Yeah, I did. I range 2474. I'm good. What about you? Can you explain the second one? I'll go through the second one again if you want. But I did that. Uh, yeah. So this is the third one. Uh, you have to maintain a global minimum, and the reason why I'm maintaining a global minimum is, uh, out of all these rows, what I want to do is I want to pick the second minimum wherever I can. So 3 and 2. I want to pick this 3 because it is greater than 2. So pick this in result, and I will pick till my queue size is equal to 1. The reason is I want to pick uh, second minimum top n minus 1 values. And basically what I want to do is the minimum, whatever is there, the minimum, I want to put it in a row which already had the least second minimum. So in this case, least second minimum is 2 here. So what I'll do, move this 1 onto the second row. So that way I have a greedy solution over here that, hey, pick the second minimum from top n minus 1 values, move uh, minimum to least second minimum row, right? Yeah, this is what you have to basically do in this question. So I'll go over the second. Just give me a minute. I'll go over the solution of this one. So here is the global minimum, which is starting from integer dot max value. Here I have a max heap, right? And this is my minimum and second minimum logic. If the second minimum doesn't exist, then I say the minimum is the second minimum. So I put that in the queue. Otherwise, I put the second minimum, and the global minimum also I keep on track of. Right. At last, I pull out all the elements except the least second minimum. And in place of least second minimum, I put the minimum one. And then I say there's, and if there is no global minimum, then what you do is you take the minimum from the queue. So this is how I was able to solve this one. I think I got a wrong answer because here I was not checking for that condition. I saw this one, that if what happens if global minimum is not there, right? Yeah. So that's how I was able to solve this one. I did it pretty quickly. Like Q1 to Q2, there is a huge gap of like 50 minutes, and then I solved it in like 20 minutes, I guess. I was also trying fourth, but I couldn't because the time was less. Okay. So Q2, some of the people are asking here. Okay, so this is how I did the Q2. I don't want to go through this again. Are you here, the code guy? So these comments I just added right now while explanation because I solved it like this. Q2 I think was more difficult than Q3 in this contest. Mhm. Yeah, Q4 I wasn't able to solve, so we can't discuss that. It was a hard Q4. because we have a very less amount of all kill today. I didn't even do the comp, or you didn't do the contest. It was a good contest. Yeah, and people sold like very quickly. What's this? Oh yeah, the external paste. Mm-hmm. Yeah, I think it is the same solution. So the thing is, okay, he has an external paste and first as well. So maybe they are solving in like external text editor. Building college project have to submit tomorrow. What is the college project that you are building? What project are you building? Yeah, yeah. But they remove some of the cheaters. My rank was like 2600, and then after an hour with the contest, they removed the cheater, so it become. Uh, I don't know why they are even cheating for what? For rating. So they are cheating for rating. They want to get a better rating. I also need to improve my rating. It is okay. I think I'll cross 1700 this contest. But yeah, people cheat because they want like the knight badge and the guardian badge. I don't know what they will do with it. But maybe they'll land some interviews with that. I don't know if recruiters see these ratings or not. Yes, so I'm done with the contest. I've discussed all the questions. Not the fourth one, apart from that Q1, Q2, Q3. Yeah, so now I'll do some random lead code questions which I haven't solved before. So I'll just put on this filter. Yeah, and I'll hit the random button, and whatever question I get, I'll try to solve it. Just a simple website combine all the online platform for sellers in one, so they don't have to manage their inventory all the time, and adding AI as have to do everything is AI after all. Yeah, AI is must for everything you add AI in. Okay, okay, I get it. Daily question. What is the daily question today? Okay, daily question. Yeah. Maximum twin sum of a linked list. Okay. In a linked list of size n, where n is even, the I plus 1th node 0 index of the linked list is known as twin of the n minus I minus 1 if for I n by I is less than equal to n by 2. Okay, minus 1. For example, if n is equal to 4, then node 0 is a twin of node 3. And if, wait, what? For example, if n is equal to 4, okay, you have 4. Let's just draw this one. The description is a bit confusing. So you have 4 nodes. You have a linked list. Right. Then node 0. So this is your 0, 1, 2, 3. Node 0 is a twin of node 3. So, okay, so 0 and 3 are twins, and 1 and 2 are twins. Okay, these are the only nodes with twins for n equal to 4. The twin sum is defined as the sum uh, of a node and its twin. Given head of a linked list with even length, return the maximum twin sum of the linked list. So if we have 5, 4, 2, 1, so we have 5, 4, 2, 1. Your sum for this will be 5 plus 1, which is 6. So this is also 6, right? All have twin sum 6. There are no other node which are twin. Thus, the maximum twin sum of the linked list is 6. And that is what you have to return. Okay, this is interesting. This is interesting. Okay. So basically, your first and last node, then this and this node is a twin. If it was an array, it was very easy. You have an L and R pointer. You can do 2 pointer on this one. But with linked list, it is a bit tricky one. And yeah, how we can solve this one? I have some ideas, but that would require your previous. Okay, so if you start from here and you somehow have a pointer over, I think this requires like reversing or something, probably. Uh, yeah, you can do some reverse operations. So 5, 4, 2, 1. Uh, Basically, what you would do is this is your first half and this is your second half of the array of the linked list. Uh, what you can simply do is you can reverse the second half. You reverse the second half. This is your linked list now, and you can keep a pointer here, and another pointer you can keep here. Uh, so this will be like 0, 1, 2, 3. So you traverse till n by 2 is what, 2, because we have 4, 4 by 2, 4. You reverse this part of the linked list. You keep a pointer over here, you keep a pointer over here, do their sum, move the pointer here and here, do the sum and take the max. I think that's how you can solve this problem. But yeah, I can go over the solution. So n by 2 minus 1, right, will land me to this position, n by 2 minus 1. Hmm. I can try to code this one. I can try to code. Hmm. Uh, if head is null, then simply return. Why the text editor so slow? Return 0 if you have no elements. And what you do is I'll take steps. And do you have n? We don't have n. Okay. So basically find the length of this linked list. Um, Length node head, node temp is head and 0, while temp is not equal to null. I don't know why this text editor is so slow. I'll reload this page. Let's see now. It is slow. But n plus plus, yeah, temp equal to temp dot next, return n. This is your length. Okay, I'll take n here. Steps is what, your n by 2 minus 1, And now you take a node current which is head, and while steps minus minus is greater than 0, um, you say current is current dot next. Then you reverse the linked list, so you do yeah, current, I think you should pass okay. So current is basically the previous node. So this node is what, 4 is current. And yeah, so I can do reverse operation on this. And what do I want to pass in? List node current or node. List node previous, I'll say, is node. This node current is equal to node dot next. And while current is not equal to null, what we will do is we do a reverse operation. Okay. Forgot the reversing of a linked list. I need to do it again. So 1, I'm here, right? Do I want to do it with recursion? Okay. So if I'm at this particular node or this particular node, this is my previous. So 4 1 2 5 4 1 2. 5 4 1 2. This is my current. This is my previous. What I'll do is I'll say previous dot next should be the end element, right? Okay. So I want to reverse this part of the linked list. Okay. I think what I can do is I can pass current to next here. And okay. List node previous, and I'll say current. Okay. Yeah, I want to reverse this linked list, and which I'm forgetting. If current is null, return the previous, I guess, because I'm trying to do it by recursion. I think there is a better way. So recursively, what I'll do is I'll go here, I'll go here. Let's say we have a 3 here. And once I'm at this position, I'll reverse this particular thing. So in reversing, once the current is here and the previous is here, I say, I call the recursive reverse current dot next. If current dot next is null, return the previous one. Okay, that returns 3. And then what you do is you say, what not the previous. Yeah. So here what you will say is this last node. So current dot next will be pointing to previous. And yeah, so you break this link, you create this link, and what you do next? But I do it like not recursively, like this will be very much easy. So if I have previous, okay, let's not do it recursively. Yeah, I think I should be able to solve it. Okay, let's not have this previous sub node. Current is node, previous is null. Let's take a dummy node here. -1. Right, we take a dummy node. And I'll say previous is dummy. So while my current is not equal to null, I say previous dot next. Okay, I need to come back to my drawing board. Let's take this 1, 2, 3. Right now current is here, previous is like a dummy node -1. So current dot next, I want to store in next. And now I want to break this link. So current dot previous is equal to, or current dot next is equal to previous. I don't think I need this either. Yeah. And now previous will be current and current will be next. Yeah, we have this operation. And let's return the previous, the last node. Right, and I'll say current dot next is equal to this. So this should ideally reverse that part, this part, second part. I think it should reverse, but I'll just print the list and see. I think I haven't done like, what do you say, linked list for a while. While current is not equal to null, system.out.print current.value, there's some space, system.out.println. Let's see, I will have to return something here. Do we have an error? Length, list node, reverse fix. Oh, I've taken note that some places. Oh, what did I do? Where it says 4. Okay. Current is current up next. 412. So this is reversed. 5412 we have, right? So we have 5412. And now my pointer 1 will be head. Plus node pointer 2 will be current dot next, I think. And yeah, so while p1 is not equal to null and p2 is not equal to null, your result is 0. Result is mat.max result and p1.val plus p2 p1 equal to p1 dot next, not p2, p1 dot next, p2 equal to p2 dot next. Okay, so this works, I think. And then we submit. Yeah, So we are able to solve this problem. I don't know what was the difficulty. I have hidden the difficulty. It was a medium. It was a decent question. Yeah. So basically, you reverse this part and then you have two pointers here and here. So you have two pointers that's starting and this point, and then you do the sum here. Do the sum of these two and these two. Yeah. Okay, so this is done, and let's come to this question. I was seeing this question, and it seemed like interesting to me. Yeah, we'll solve this one. Hmm. I'll just take a small water break. Yeah. Let's see this question. Read this one. Okay. You're given two integer height and width representing a garden. Okay. You're given an array of trees. Tree position is given. Squirrel position is given. Nuts position is given. Okay. The squirrel can take at most one nut at a time and move in four directions. Hmm. Okay, so the question says this is what we have, right? And okay, the squirrel can take this nut and then move it to this position. I can draw. I can draw. Sorry. Yeah. So 12. So if I think in terms of like BFS, it's basically okay, this cell or this cell. Then from here, this cell. Then from here, this cell. So, or this cell, right? So this squirrel can take this nut in like what distance? One, two, three, three distance. And then what is the distance from this to this minimum distance? Yeah. And then the squirrel will be on this tree. So three. Uh, so I think I need to erase these things. So I'll just draw a path here, 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 then here, here, here. So these are like 1, 2, 3, 4, 5, 6. 6 for the first one. Then from here, 1, 2, 3. And then back. 4, 5, 6. 6 on the second one. So 6 and 6 is 12. And the answer is 12. Okay. Okay. Hmm. So I think I want answers to two questions. Uh, so not to squirrel distance and not to tree distance. So if I do the BFS and whatever nut comes first, I'll pick that one. What are the constants? The constant must be like small for this question. It's 100 cross 100. Okay. 6,000. No, 1,000. 10,000. Okay. Hmm. This is an interesting question. Uh, can I find the closest nut from this position? So squirrel to nut to tree and then nut to tree. Okay, I'm thinking. Oh, okay. Hmm. I think this never changes. So this particular path never changes. This and this never changes. This and this also never changes. But the squirrel position changes. So I think this is just squirrel to closest nut, which can be done using BFS. And then you calculate the distance between uh the shortest distance between a nut and a path, nut and a tree, right? So nut comma tree ka distance for each nut. Okay, I think some maths there and we'll be able to solve this one. This is interesting. Okay, so you can go over a tree as well. 1, 2, 3. Okay. Okay. There can only be one tree, one squirrel. Nuts can be many. Tree can be one. Yeah. Okay. Let's solve it like one thing at a time. Okay, we have of things. Do I want to draw this grid? Hmm. Or what I can do is this thing I can reverse, not to squirrel shortest. Hmm. Do I want to store a map or this is difficult question. Okay. Um I think I will need this array. Hmm. Okay, and rows and columns. Let's take a queue of sure and for and squirrel. Hmm. Mm. Okay. Mm, mm, mm. Priyanshu Sharma. Hi, Priyanshu. So this is 0. Zeroth squirrel is no, zeroth nut is 3 comma 0. So 3 comma 0 to this tree, the distance is okay. I think I have to do bit masking. Because this will be 3 distance, which is fine. But from here till here, it should had a distance like, oh, okay. Maybe this is the issue. The distance is still -1. Hmm. So when I'm here, I do a BFS. This. Okay, this is fine. This is I. Hmm. Second is fine. This is -1, which is weird. Why is this -1? Because when I'm here, I'll go to the tree. Oh, maybe it is because when I'm here on this one, I visit the tree and mark the tree is visited. That can be the case. Should I not mark the tree as visited? Or I should do another BFS. I think doing another BFS to get the path from the tree to this nut is much more simpler. I think I can simplify my logic. I can break here and then I can do these things. I can move down here. New linked list and q dot offer new r tree 0 tree column the distance 0. Renshaw, are you still here? So I'm solving this question. Okay. I don't know if I need like two BFS. I'm simplifying this one. Uh, Current of one and if this is the part where I would have to store this um nuts into like a set to do this efficiently because nuts can be 5,000. So I'll also do that. Set of list of integers. That's it. Okay. Can't store in a I. I can store. Basically, I want the distance of this tree to the other nuts. This. The thing is, we can like visit, I think, multiple times. So if there was one more nut here, I visit this. Can I have another shorter distance that is this? Hmm. This is tricky. I need to see the topic. It says array and maths. Okay. Maybe I'm not doing it correct, but okay, if it is maths. I still need to find this distance. Okay, the trees on this distance. Can I more efficiently calculate this distance? Hmm. So the distance to squirrel, let's say this part is sorted. Let's say this thing is sorted. I want to find the distance between this tree and this and this and this. So this is basically what if I say Manhattan distance, it will be your absolute of the tree row minus the nut row plus absolute of tree column minus nut column, right? Yeah, I think this should give me the distance from nut. Let's try to do this one. So let's say this part is sorted for now. Hmm. This part is sorted. So let's take distance n, and for each uh, tree row is tree 0, tree column is tree. Nuts of I, nut row is nut of 0, nut column is nut of 1. The distance of I is mat dot abs, nut row minus tree row plus mat dot abs nut column minus tree column. Yeah, and then the closest, if it is this 0 to 3, 0 to 3, I think we should be good. Let's try to run this one. Okay, we have a wrong answer on this. Okay. Oh. Uh, do I also need to consider like the squirrel distance, shortest squirrel distance also? Hmm. Hi, striver to lead code 07. Hello, how are you doing? I'm solving this question, squirrels simulation. This is a difficult one. But I was thinking BFS initially, and then I moved to like some maths, Manhattan distance. And I think if I just do sort the squirrel distance in the least squirrel distance. Oh, this is difficult. Oh, I need to think. Let's just print this thing first. Mm, square distance. N. Okay. Hmm. Okay. This distance is 5. This distance is there. Hmm. Hmm. Okay. Hmm. I think there is some greedy idea. I think I need to see. I want some hint on this one. I think choose, yeah, the hint also says it. But choosing the first nut is difficult. You cannot just choose any nut. Okay. What if I don't do this, do this, and I say that for each min index 0 till mm, no, this was hard. This has to be a hard question. Oh, it's a medium question. Yeah. So basically, I tried like I'll pick this nut first, and then what is the answer? If I pick this nut first, what will be the answer? Basically, that was what I did. Oh, it took some time. Yeah, I was able to get it accepted. What do people say? Yeah, I did the same. BFS idea. This was a nice question. Hmm. Okay. I've been streaming for like 1 hour 40 minutes. Hmm. I don't see many chatters today, so let's just close this stream because we discussed the 506 contest and we solved one good question. Yeah, that's it for this stream, and